The Greeks, Egyptians, and Chinese, among others, were pioneers of their era, laying the groundwork for future scientific advancements. Make sure to press the subscribe button and enable push notifications if you want to keep up with our fascinating articles and participate in our active community of like-minded people. Pythagoras, a revered mathematician and philosopher, is renowned for his groundbreaking theorem in geometry, known as the Pythagorean theorem. This theorem, which establishes a fundamental relationship between the sides of a right-angled triangle, revolutionized the field of mathematics and remains a cornerstone of geometric principles. Aristotle, a true polymath and one of history's most influential thinkers, ventured into a multitude of scientific disciplines. Aristotle's observations and classifications of plants and animals formed the basis for later scientific investigations, and his work on physics contributed to our understanding of motion, matter, and the natural world. The Greeks' unwavering curiosity and dedication to scientific exploration fueled an era of remarkable discoveries. Meanwhile, while ancient Egypt is celebrated for its awe-inspiring architectural wonders, such as the magnificent pyramids that still stand tall today, it is equally important to recognize the profound scientific knowledge that thrived within this ancient civilization. The Egyptians were not only master builders but also possessed a remarkable understanding of medicine and astronomy. They believed in the concept of balance and harmony within the body, and their medical treatments aimed to restore this equilibrium. Physicians in ancient Egypt were skilled in diagnosing various ailments and employed a combination of practical techniques, spiritual rituals, and medicinal herbs to treat their patients. From setting broken bones to performing complex surgical procedures, the Egyptians demonstrated a level of medical expertise that was far ahead of its time. Moreover, the Egyptians had a profound fascination with the night sky and were avid astronomers. They carefully observed celestial bodies and developed a sophisticated understanding of the movements of the stars, planets, and constellations. The construction of monumental structures, such as the Great Sphinx and the temples aligned with astronomical phenomena, further attests to the Egyptians' profound knowledge and reverence for the cosmos. As we delve into the rich tapestry of ancient civilizations, we mustn't overlook the remarkable contributions of ancient China to the realm of science. In this vast and diverse land, the pursuit of knowledge flourished, and visionary individuals like Zhang Heng emerged as pioneers in multiple scientific disciplines. Zhang Heng, a polymath of extraordinary talent, made profound advancements in the fields of astronomy, mathematics, and mechanics. One of his most notable achievements was the creation of a sophisticated seismograph that could detect and measure earthquakes. This ingenious device, known as the earthquake weathercock, utilized an intricate system of gears and levers to accurately sense seismic activity. Beyond his contributions to seismology, Zhang Heng also made significant strides in astronomy. He meticulously observed celestial phenomena and developed a celestial globe that depicted the positions of stars and planets with remarkable precision. His celestial map not only contributed to our understanding of the cosmos but also laid the foundation for subsequent astronomical studies in China. However, the scientific prowess of ancient China extended far beyond the realms of astronomy and mechanics. The Chinese were pioneers in agricultural techniques, developing sophisticated methods to improve crop yields and ensure food security for the vast population. They introduced revolutionary techniques such as crop rotation, irrigation systems, and the use of fertilizers, which greatly enhanced agricultural productivity and transformed farming practices. Moreover, the Chinese were masters of invention, devising groundbreaking technologies that revolutionized human civilization. One such invention was papermaking, a transformative development that propelled the dissemination of knowledge and the spread of literacy. The invention of the compass, a navigational tool that revolutionized maritime exploration, is another testament to the Chinese ingenuity and their quest for scientific progress. Let us now journey to the ancient Middle East, a region that witnessed extraordinary scientific advancements and played a pivotal role in shaping the foundations of modern science. One of the most remarkable civilizations in the ancient Middle East was Mesopotamia, known as the land between the rivers Tigris and Euphrates. Mesopotamian scholars, known as cuneiform scribes, made significant contributions to diverse fields of knowledge, including mathematics, astronomy, and medicine. In the realm of mathematics, the Mesopotamians developed a sophisticated numeral system based on the concept of positional notation, paving the way for the development of advanced mathematical calculations. They also formulated intricate mathematical algorithms and geometric principles, which were used in various practical applications such as land surveying, construction projects, and trade. Astronomy held great importance in ancient Mesopotamia, as the observation of celestial bodies played a crucial role in religious and agricultural practices. Mesopotamian astronomers meticulously recorded astronomical events, predicting the movements of the sun, moon, and planets with remarkable accuracy. They developed intricate calendars to guide agricultural activities and religious ceremonies, showcasing their deep understanding of the celestial motions. In the field of medicine, ancient Middle Eastern civilizations made significant strides in understanding the human body and developing effective medical treatments. They documented their medical practices on clay tablets, creating one of the earliest known medical texts, which included detailed descriptions of diseases, symptoms, and treatment methods. Ancient science was not limited to these civilizations alone. Across the globe, indigenous cultures made significant contributions to fields like astronomy, navigation, and botany. Their profound connection with the natural world enabled them to understand celestial phenomena and utilize the Earth's resources for sustenance and healing. As we marvel at the achievements of these early civilizations, it is important to recognize the controversies and limitations of ancient science. Cultural biases, limited technological tools, and the absence of modern scientific methodologies undoubtedly affected the accuracy and scope of their findings. Yet, it is precisely through these challenges and imperfections that we can appreciate the remarkable achievements of our predecessors. The ancient world was a crucible of scientific knowledge and discovery. The Greeks, Egyptians, Chinese, and many other ancient civilizations laid the foundations for future generations to build upon. In the Middle Ages, scientific progress was heavily intertwined with religious institutions, shaping the course of inquiry in fields such as natural philosophy, alchemy, and astrology. Among the luminaries of medieval science, Islamic scholars played a pivotal role in driving groundbreaking discoveries and advancing the frontiers of knowledge. One such scholar who made an indelible mark on the scientific world was Ibn al-Haytham, also known as Al-Hazan. Ibn al-Haytham's contributions to the field of optics revolutionized our understanding of light and vision. His magnum opus, the Book of Optics, remains one of the most influential scientific works in history. In this seminal text, he meticulously explored various aspects of optics, including light refraction, reflection, and the mechanics of vision. By dissecting the complexities of how light interacts with different mediums and how it is perceived by the human eye, Ibn al-Haytham laid the foundation for the scientific method. What set Ibn al-Haytham apart from his contemporaries was his rigorous approach to empirical observation and experimentation. He understood the critical role that systematic investigation played in unraveling the mysteries of the natural world. Ibn al-Haytham conducted numerous experiments to test his theories, applying mathematical analysis to interpret the results. This methodical approach marked a significant departure from prevailing philosophical traditions that relied heavily on speculative reasoning and abstract thought. Ibn al-Haytham's emphasis on empirical evidence and mathematical analysis became a cornerstone of the scientific method, setting a new standard for scientific inquiry. In addition to Ibn al-Haytham, there were other notable Islamic scholars who made significant contributions to medieval science. One such figure was Jabir ibn Hayyan, known in the Western world as Geber. Jabir was a polymath who delved into various fields, including alchemy, chemistry, and medicine. His extensive writings on alchemy introduced numerous chemical processes and experimental techniques that laid the groundwork for modern chemistry. Jabir's works greatly influenced the development of alchemy in Europe and provided a bridge between ancient Greek knowledge and the scientific advancements of the Islamic world. Another remarkable Islamic scholar was al-Kindi, also known as the philosopher of the Arabs. Al-Kindi was a prolific writer who explored diverse subjects such as philosophy, mathematics, medicine, and astronomy. His works on mathematics played a crucial role in introducing Indian numerals to the Islamic world, which eventually spread to Europe and became the foundation of our modern numeral system. Al-Kindi's contributions to astronomy included translating and expanding upon ancient Greek astronomical works, aiding in the preservation and transmission of astronomical knowledge. In the Christian world, amidst the intellectual landscape of the Middle Ages, there were notable scholars who emerged as pioneers of scientific inquiry. One such luminary was Roger Bacon, a Franciscan friar whose unwavering dedication to empirical observation and experimentation challenged the prevailing intellectual climate of his time. Roger Bacon passionately advocated for a new approach to understanding the natural world, one that relied on direct observation and empirical evidence rather than blind adherence to authority and dogma. He believed that knowledge could only be obtained through sensory experience and the meticulous gathering of data. Bacon emphasized the crucial role of experimentation in verifying and expanding upon existing knowledge, rejecting unfounded assumptions and baseless theories. Bacon's groundbreaking work in experimental science laid the foundation for the empirical approach to scientific inquiry that would later flourish during the Renaissance. He recognized the significance of mathematics as a powerful tool for analyzing and interpreting data, paving the way for the integration of mathematical reasoning into scientific investigations. Bacon understood that mathematics provided a universal language through which the complexities of the natural world could be unraveled and explained. In addition to Roger Bacon, other Christian scholars made notable contributions to medieval science. One such figure was Albertus Magnus, a Dominican friar known for his extensive work in the natural sciences. Albertus Magnus delved into diverse fields such as chemistry, biology, and physics, and his writings encompassed a wide range of topics including botany, zoology, and geology. He emphasized the importance of systematic observation and cataloging of natural phenomena, making significant advancements in the classification and study of plants and animals. Another influential Christian scientist was Robert Grosseteste, an English bishop and philosopher. Grosseteste's work encompassed a broad range of disciplines, including optics, mathematics, and astronomy. He made significant strides in the study of light and color, conducting experiments to investigate the properties of lenses and the nature of rainbow formation. Grosseteste's treatises on optics laid the groundwork for future advancements in this field, and his emphasis on observation and empirical analysis contributed to the growing scientific spirit of the time. Both Islamic and Christian scholars faced challenges and tensions in their pursuit of scientific truth. Within the Islamic world, religious beliefs and institutions provided a supportive environment for scientific inquiry, enabling scholars to thrive and make remarkable advancements. However, as time progressed, religious conservatism and dogmatism began to stifle scientific progress, resulting in a decline in scientific achievements. In the Christian realm, the relationship between science and religion was complex. While some Christian scholars faced resistance from ecclesiastical authorities who viewed scientific pursuits with suspicion, others found support within monastic orders and religious institutions that saw value in exploring the natural world as a reflection of divine order. Furthermore, the prevalent belief in alchemy and astrology, popular during the Middle Ages, raised controversy within the scientific community. Alchemy, often associated with the pursuit of turning base metals into gold, was not solely a quest for material wealth but also a philosophical and mystical exploration. While it laid the groundwork for chemical processes and laboratory techniques, alchemy was heavily laden with symbolic and esoteric elements that challenged its scientific credibility. Similarly, astrology, with its emphasis on celestial bodies and their influence on human affairs, was regarded as a legitimate science during this period. However, its claims lacked empirical evidence and were met with skepticism by some scholars. As we reflect on the complexities of medieval science, it is important to appreciate the context in which these scientific endeavors unfolded. While religious influences posed challenges to scientific progress, they also provided a platform for intellectual pursuit and preserved knowledge from ancient civilizations. The Middle Ages served as a bridge between the ancient world and the scientific advancements of the Renaissance. During the Renaissance, Europe experienced a profound rebirth of interest in the natural world. Scholars and thinkers emerged from the shadows of medieval dogma, embracing a fresh approach to knowledge grounded in observation and reason. The seeds of scientific revolution were sown, as individuals dared to question long-held beliefs and seek answers through empirical investigation. One of the luminaries of this era was Nicolaus Copernicus. Nicolaus Copernicus, a visionary astronomer and mathematician, played a pivotal role in reshaping our understanding of the cosmos during the Renaissance and early modern period. In an era dominated by the geocentric model, which placed the Earth at the center of the universe, Copernicus dared to question the established order. His revolutionary heliocentric theory, presented in his seminal work, De Revolutionibus Orbium Coelestium, on the revolutions of the celestial spheres, defied conventional wisdom and propelled humanity into a new era of astronomical understanding. Copernicus's audacious proposition that the Earth revolves around the Sun challenged centuries of ingrained beliefs and rocked the foundations of astronomical understanding. By placing the Sun at the center of the solar system, Copernicus illuminated the true nature of our celestial neighborhood. His meticulous observations and mathematical calculations supported his theory, providing a compelling alternative to the prevailing geocentric model. This profound paradigm shift in cosmology, known as the Copernican Revolution, forever altered our perception of the universe and paved the way for further scientific discoveries. However, Copernicus's groundbreaking ideas did not come without opposition. The geocentric model, deeply rooted in religious and philosophical traditions, faced resistance from those who saw Copernican theory as a challenge to their worldview. The clash between scientific progress and religious authority created tensions that would persist throughout the era. Nevertheless, Copernicus's courage to challenge the status quo and his relentless pursuit of truth laid the groundwork for future generations of scientists to build upon. The impact of Copernicus's heliocentric theory extended far beyond the field of astronomy. It ignited a spark of intellectual curiosity and set the stage for a broader scientific revolution. By questioning the geocentric model, Copernicus opened the doors for further scientific exploration and inquiry. His work inspired generations of scientists, including Galileo Galilei and Johannes Kepler, who built upon his ideas and expanded our knowledge of the cosmos. Nicolaus Copernicus stands as a towering figure in the history of science, a trailblazer whose heliocentric theory transformed our understanding of the universe. His courage, curiosity, and commitment to empirical observation set a powerful example for future generations of scientists. The Copernican revolution sparked a paradigm shift that continues to resonate with us today, reminding us of the transformative power of daring to challenge established beliefs. As the Renaissance blossomed, so did the spirit of scientific inquiry. The era witnessed the rise of brilliant minds like Galileo Galilei, whose pioneering work in physics and astronomy propelled us towards a deeper understanding of the natural world. Galileo Galilei, an Italian polymath and scientist, made groundbreaking contributions to the fields of physics and astronomy that would forever change our perception of the cosmos. His revolutionary use of telescopes and meticulous observations allowed him to peer into the depths of the universe with unprecedented clarity. Through his observations of celestial bodies, Galileo gathered compelling evidence to support the heliocentric model, which placed the Sun at the center of the solar system. However, Galileo's bold endorsement of the heliocentric model, aligning with the ideas put forth by Copernicus, clashed with the prevailing geocentric views of the time. His scientific pursuits brought him into direct conflict with the religious authorities, who saw his findings as a challenge to their established doctrines. Despite facing persecution and condemnation, Galileo steadfastly defended his discoveries and advocated for the pursuit of empirical evidence over blind adherence to dogma. Galileo's courage and determination to speak the truth in the face of opposition made him a symbol of scientific integrity and resilience. His unwavering commitment to the pursuit of knowledge and the use of empirical methods laid the foundation for modern scientific inquiry. Galileo's groundbreaking work not only confirmed the heliocentric model but also pioneered the study of dynamics and the laws of motion, contributing to the birth of modern physics. It is essential to recognize that Galileo's story is a testament to the complexities of the relationship between science and religion during this period. The clash between scientific progress and established religious institutions reflects the inherent tension between tradition and the pursuit of knowledge. Galileo's experience serves as a stark reminder of the courage required to challenge prevailing beliefs and the importance of defending scientific truth, even in the face of adversity. Leonardo da Vinci, a true polymath, possessed an insatiable curiosity that drove him to explore and understand the world around him. His artistic genius transcended the boundaries of conventional artistry, as he sought to capture not only the aesthetic beauty but also the scientific intricacies of his subjects. In his pursuit of understanding human anatomy, da Vinci embarked on meticulous dissections, documenting his findings through intricate and detailed anatomical drawings. Through his precise and groundbreaking anatomical studies, da Vinci revealed the hidden wonders and complexities of the human body. His illustrations provided unprecedented insights into the structures and functions of various organs, muscles, and skeletal systems. Da Vinci's keen observational skills allowed him to depict anatomical details with remarkable accuracy, setting a new standard for anatomical study. Furthermore, da Vinci's fusion of art and science extended beyond anatomy. His fascination with engineering and inventions led him to conceptualize innovative machines and designs that were far ahead of their time. From flying machines to canal systems and military weaponry, da Vinci's ingenious ideas reflected his profound understanding of mechanics and engineering principles. Da Vinci's contributions to the fields of anatomy, art, and engineering epitomized the multidisciplinary approach of the Renaissance. His meticulous anatomical drawings not only advanced our knowledge of human physiology but also inspired future generations of scientists and medical professionals. His engineering designs, although never fully realized during his lifetime, laid the groundwork for numerous technological advancements in the centuries that followed. The impact of da Vinci's work extends far beyond his own time, as his insights and innovations continue to inspire and shape our understanding of the world. His relentless pursuit of knowledge and his ability to bridge the gap between art and science embody the essence of the Renaissance spirit. Da Vinci's legacy serves as a testament to the power of interdisciplinary exploration and the transformative potential of embracing diverse fields of study. Yet, the Renaissance and early modern era was not a harmonious journey towards scientific enlightenment. It was marked by conflicts and controversies as scientific progress collided with deeply entrenched religious beliefs. These clashes of ideas created significant tensions and led to the persecution of individuals who dared to challenge the established order. One such figure was Giordano Bruno, a brilliant philosopher and cosmologist whose radical ideas about the nature of the universe shook the foundations of the prevailing religious doctrines. Bruno proposed a revolutionary concept of an infinite universe populated with countless inhabited worlds, a notion that directly contradicted the traditional religious view of a geocentric cosmos with Earth at its center. Bruno's audacious ideas challenged the religious authority of the time and posed a direct threat to the established order. His steadfast refusal to renounce his beliefs and conform to the dogmas of the Church ultimately led to his tragic fate. In 1600, Bruno was condemned as a heretic, and he was burned at the stake in Rome. The persecution and execution of Giordano Bruno serve as a stark reminder of the struggles faced by those who dared to challenge the status quo during this period. His courageous pursuit of knowledge and his willingness to challenge deeply ingrained beliefs cost him his life, but his ideas continued to reverberate throughout history. While conflicts between science and religion were prevalent during this era, it is important to note that not all religious institutions opposed scientific progress. Some religious thinkers, such as Jesuit astronomers, recognized the value of scientific inquiry and actively engaged in astronomical research. They sought to reconcile their religious beliefs with the growing body of scientific knowledge, contributing to the advancement of astronomy and other fields. The tensions and conflicts between science and religion during the Renaissance and early modern period highlight the complex relationship between these two spheres of human endeavor. It is a reminder that progress and innovation often face resistance from established norms and beliefs. However, it is also a testament to the enduring power of human curiosity and the indomitable spirit of those who dared to question and explore the boundaries of knowledge. However, amidst the clashes and controversies, the flame of scientific curiosity burned ever brighter. The early modern period witnessed a surge of innovative discoveries and inventions that propelled humanity forward. Renowned scientists like Isaac Newton, through his monumental work on gravity and laws of motion, unlocked the secrets of the universe, forever altering our understanding of physics. The Renaissance and early modern period marked a pivotal chapter in the history of science, one that shattered long-standing dogmas and propelled humanity towards a new era of knowledge and progress. The Enlightenment, a period of intellectual and philosophical enlightenment that spanned the 17th and 18th centuries, revolutionized the way we perceive the world. It was a time when reason and rationality took center stage, casting aside the shackles of blind faith and superstition. Scholars and thinkers emerged from the shadows of tradition, daring to question the established order and paving the way for a new era of knowledge and progress. At the heart of the Enlightenment beat the resounding belief in the inherent power of human reason. This intellectual and philosophical movement brought forth a wave of brilliant thinkers who dared to question the prevailing order and challenge the authority of the church and monarchies. Among them stood René Descartes, John Locke, and Immanuel Kant, whose revolutionary ideas about the nature of knowledge, individual rights, and the pursuit of truth would shape the course of history. René Descartes, a French philosopher, mathematician, and scientist, played a pivotal role in the Enlightenment with his groundbreaking work in rationalism. Descartes advocated for the primacy of reason as the foundation of knowledge. He famously declared, "Cogito, ergo sum," I think, therefore I am, emphasizing the importance of individual thought and self-awareness. By placing human reason at the forefront, Descartes challenged the authority of external institutions and invited individuals to critically examine the world around them. John Locke, an English philosopher, took the Enlightenment ideals further by exploring the concepts of individual rights and limited government. His influential works, such as Two Treatises of Government, argued that political authority should be derived from the consent of the governed. Locke championed the idea that individuals possess natural rights, including life, liberty, and property, and that governments exist to protect and uphold these rights. Immanuel Kant, a German philosopher, synthesized the ideas of his predecessors and expanded upon them in his influential work, Critique of Pure Reason. Kant emphasized the importance of individual autonomy and moral reasoning. He believed that humans have the capacity to discern universal moral principles through their rational faculties. Kant's concept of the categorical imperative urged individuals to act according to principles that could be universally applied, emphasizing the inherent dignity and rationality of all human beings. These Enlightenment thinkers collectively challenged the prevailing authority of the church and monarchies, advocating for the sovereignty of reason and the importance of individual autonomy. They sought to liberate humanity from the constraints of dogma, superstition, and arbitrary power. In their pursuit of truth, these Enlightenment thinkers sparked a philosophical and intellectual revolution that would shape the course of human history. The legacy of these thinkers endures to this day, reminding us of the transformative power of reason, individual rights, and the pursuit of truth. But the Enlightenment, like any transformative movement, was not without its controversies. As the brilliant light of reason illuminated the intellectual landscape, it also exposed the deep-rooted inequalities and injustices embedded within society. The prevailing systems of power and privilege that had long held sway were suddenly cast into sharp relief, sparking heated debates and fervent discussions about equality, human rights, and social justice. Prominent philosophers of the time, such as Voltaire, Jean-Jacques Rousseau, and Mary Wollstonecraft, emerged as influential voices in these critical conversations. Voltaire, a French writer and philosopher, used his sharp wit and biting satire to criticize the abuses of power and the injustices he witnessed. Through his writings, including the famous novel, Candide, he exposed the hypocrisy of the nobility and religious intolerance, advocating for freedom of thought, religious tolerance, and the importance of civil liberties. Voltaire's relentless pursuit of truth and his unwavering commitment to justice made him a powerful advocate for reform and a champion of individual rights. Jean-Jacques Rousseau, a Genevan philosopher and writer, examined the nature of society and its impact on human beings. His influential work, The Social Contract, explored the concept of a social compact, where individuals willingly come together to form a just and harmonious society. Rousseau argued for the inherent equality of all individuals and criticized the stark divisions of wealth and power that perpetuated social inequality. His ideas laid the groundwork for democratic principles, emphasizing the importance of popular sovereignty and the collective pursuit of the common good. Mary Wollstonecraft, an English writer and philosopher, made a profound impact on feminist thought during the Enlightenment. In her seminal work, A Vindication of the Rights of Woman, Wollstonecraft passionately argued for the equal education and rights of women. She challenged the prevailing notion that women were intellectually inferior and advocated for their active participation in society. Wollstonecraft's groundbreaking ideas paved the way for the feminist movement, inspiring generations of women to fight for their rights and challenge societal norms. These philosophers, among many others, bravely confronted the inequalities and injustices of their time. They fearlessly questioned the entrenched systems of power and privilege, demanding a more just and inclusive society. Their ideas ignited a flame of social consciousness that continues to burn brightly today, inspiring ongoing struggles for equality and social justice. The scientific revolution, which unfolded during the same period, went hand in hand with the Enlightenment. It was a time of remarkable discoveries and paradigm shifts that transformed our understanding of the natural world. Visionaries like Nicolaus Copernicus, Galileo Galilei, and Isaac Newton overturned long-held beliefs, replacing them with empirical evidence and rigorous scientific methods. Isaac Newton, a towering figure in the history of science, made groundbreaking contributions that forever transformed our understanding of the physical world. Born in 1643 in Woolsthorpe, England, Newton's intellectual brilliance and insatiable curiosity set him on a path of discovery that would revolutionize physics and mathematics. Newton's most famous work, Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, published in 1687, laid the foundation for classical mechanics and introduced his three laws of motion. These laws, known as Newton's laws, provided a unified framework for understanding the motion of objects and the forces acting upon them. With his laws, Newton unraveled the mysteries of gravity, demonstrating that it is the force responsible for both the motion of celestial bodies and the falling of an apple from a tree. The concept of universal gravitation, a cornerstone of Newton's work, brought together the realms of astronomy and physics. By postulating that every particle of matter attracts every other particle with a force proportional to their masses and inversely proportional to the square of the distance between them, Newton provided a mathematical framework that could explain the motion of the planets, the tides, and other celestial phenomena. His mathematical equations allowed scientists to calculate the trajectories of planets, comets, and other celestial bodies with remarkable precision. Newton's discoveries were not limited to celestial mechanics. He also made significant advancements in optics. Through his experiments with light, Newton showed that white light is composed of a spectrum of colors and that each color represents a different wavelength. He invented the reflecting telescope, which utilized mirrors instead of lenses to capture and focus light, overcoming some of the limitations of traditional refracting telescopes. Newton's insights into optics laid the foundation for the field of spectroscopy and paved the way for future breakthroughs in understanding the nature of light. Newton's contributions extended beyond his scientific achievements. He developed calculus as a powerful mathematical tool to solve complex problems involving rates of change, becoming one of the co-creators of this fundamental branch of mathematics. His work on the laws of motion and calculus provided a solid foundation for the scientific revolution of the 17th and 18th centuries and laid the groundwork for the development of modern physics. However, Newton's genius was not without controversy and complexities. Despite his immense contributions, he had a reputation for being a difficult and sometimes contentious figure. He was known to fiercely guard his intellectual property and engage in disputes with other scientists, most notably with German mathematician and philosopher Gottfried Leibniz over the invention of calculus. Yet, Newton's impact on science and human understanding cannot be overstated. His laws of motion and theory of gravity provided a revolutionary framework that explained the motion of objects on Earth and in the cosmos. Newton's work laid the groundwork for future generations of scientists, inspiring further exploration and discovery. His profound influence can be seen in the subsequent development of physics, engineering, and astronomy, shaping our understanding of the universe and our technological advancements. The Enlightenment and the scientific revolution were not isolated events but interconnected movements that challenged the foundations of society. They sparked a revolution of thought, ushering in a new era of intellectual freedom, scientific inquiry, and the pursuit of truth. The Industrial Revolution, characterized by rapid industrialization and technological advancements, marked a pivotal turning point in human history. As factories emerged, powered by steam engines and machinery, a new era of scientific practices took hold. Innovations in manufacturing and transportation not only fueled economic growth but also fueled the fires of scientific curiosity. During the Industrial Revolution, the field of physics underwent a momentous transformation, propelling humanity into a new era of scientific understanding. Within this period of technological advancements and industrialization, brilliant minds emerged to revolutionize our comprehension of energy, motion, and electromagnetism. Among these luminaries, Michael Faraday and James Clerk Maxwell played pivotal roles in shaping the landscape of classical electrodynamics. Faraday, a self-taught scientist and experimentalist, dedicated his life to unraveling the mysteries of electricity and magnetism. Through his tireless experiments, he discovered electromagnetic induction, demonstrating the interplay between electricity and magnetism and providing a crucial stepping stone for future breakthroughs. Building upon Faraday's foundations, James Clerk Maxwell expanded the frontiers of knowledge with his brilliant mathematical formulations. Maxwell's equations, a set of fundamental equations describing the behavior of electric and magnetic fields, unified the theories of electricity and magnetism into a single, elegant framework. This unification revealed the profound interconnectedness of these phenomena, offering profound insights into the fundamental forces shaping the universe. Maxwell's equations not only provided a powerful tool for predicting and understanding the behavior of electromagnetic waves, but they also paved the way for the development of modern technologies. From the telegraph to wireless communication, from electric power distribution to the marvels of modern electronics, Maxwell's work underpins the foundation of our interconnected world. The implications of Faraday and Maxwell's groundbreaking discoveries were far-reaching, transcending the boundaries of physics. Their profound insights laid the groundwork for subsequent scientific breakthroughs, opening doors to transformative technologies and revolutions in countless other fields. The pursuit of knowledge during the Industrial Revolution was a tumultuous journey marked by controversial and paradigm-shifting scientific discoveries. As our understanding of the natural world expanded, these groundbreaking findings often collided with deeply ingrained religious and philosophical beliefs, giving rise to a fervent clash between science and established doctrines. One of the most contentious figures of this era was Charles Darwin, whose theory of evolution through natural selection sent shockwaves through the scientific and religious communities. In his seminal work, On the Origin of Species, Darwin presented a compelling argument for the gradual development and diversification of species over time, challenging the prevailing belief in divine creation and the notion of a fixed, unchanging natural order. Darwin's theory posed a profound challenge to religious institutions, as it questioned the traditional understanding of humanity's place in the world. The concept of human beings sharing a common ancestry with other species was met with resistance and even condemnation from those who saw it as a direct contradiction to religious teachings. The clash between science and religion fueled intense debates that reverberated throughout society, permeating classrooms, pulpits, and public discourse. The controversy surrounding Darwin's theory of evolution highlighted the fundamental tension between scientific progress and deeply held beliefs. While some embraced Darwin's ideas as a liberating force, others vehemently rejected them, seeking to preserve the traditional interpretations of religious texts and doctrines. Marie Curie, an extraordinary figure in the history of science, fearlessly ventured into the realm of radioactivity and forever changed our understanding of the natural world. As a trailblazer in her field, Curie pushed the boundaries of scientific exploration, demonstrating unparalleled dedication and intellect. Her groundbreaking research on radioactive elements, particularly radium and polonium, not only earned her multiple Nobel Prizes but also heralded a new era of scientific discovery. However, Curie's relentless pursuit of knowledge came at a great personal cost. The very substances she studied with such passion and determination posed significant health risks. Constant exposure to radiation took its toll on her well-being, leading to chronic health issues and ultimately contributing to her untimely demise. Despite the risks, Curie remained undeterred, driven by an insatiable curiosity and a fervent belief in the transformative power of scientific inquiry. Curie's work went far beyond mere academic pursuits. Her discoveries in the realm of radioactivity revolutionized various fields, particularly medicine and radiation therapy. However, the path forged by Curie was not without ethical dilemmas and concerns. The potential dangers associated with radioactivity became apparent as its use expanded. Questions arose about the responsible handling and regulation of radioactive materials, as well as the long-term effects of exposure on both scientists and the general population. Curie's own struggles with health issues served as a poignant reminder of the risks inherent in scientific pursuits and the need for meticulous safeguards. During the Industrial Revolution, engineering emerged as a formidable scientific discipline, forever altering the course of human history. Visionary engineers such as Isambard Kingdom Brunel and Thomas Edison harnessed the transformative power of steam and electricity, catalyzing a wave of revolutionary advancements in transportation, communication, and infrastructure. Isambard Kingdom Brunel, a true engineering genius of his time, spearheaded monumental projects that redefined the possibilities of transportation. He masterminded the construction of iconic railway networks, including the Great Western Railway, which connected major cities and propelled the Industrial Revolution forward. Brunel's innovative engineering solutions, such as the ingenious use of prefabricated components and the construction of impressive tunnels and bridges, set new standards for efficiency and durability. Meanwhile, Thomas Edison, the renowned American inventor, brought the brilliance of electricity to the forefront of human progress. His groundbreaking inventions, including the phonograph and the electric light bulb, revolutionized communication and lighting, forever transforming the way we live. Edison's relentless pursuit of innovation and his tireless experiments in his Menlo Park laboratory pushed the boundaries of what was thought possible, illuminating the world and opening up new horizons of convenience and comfort. These creative engineering feats not only improved the quality of life but also propelled humanity into an entirely new era of innovation and convenience. The advent of steam-powered locomotives and the electrification of cities brought people closer together, facilitating trade, travel, and cultural exchange on an unprecedented scale. The construction of magnificent bridges and tunnels not only connected previously isolated regions but also symbolized the triumph of human ingenuity over nature's formidable obstacles. However, the rise of engineering during the Industrial Revolution was not without its challenges. The rapid pace of technological advancements often outstripped the ability to implement proper safety measures and regulations. Accidents and disasters, such as bridge collapses or boiler explosions, served as grim reminders of the complex relationship between progress and the need for responsible engineering practices. In this period, Albert Einstein, one of the greatest scientific minds in history, left an indelible mark on the world with his revolutionary theories and profound insights. Born in Germany in 1879, Einstein's contributions to the fields of physics and mathematics fundamentally transformed our understanding of the universe. Einstein's most famous and groundbreaking theory is the theory of relativity. In 1905, he published his special theory of relativity, which revolutionized our understanding of space, time, and motion. This theory proposed that the laws of physics are the same for all observers, regardless of their relative motion. It introduced the concept of the constant speed of light, challenging the long-held Newtonian notions of absolute space and time. Einstein's theory of relativity paved the way for remarkable advancements in physics and laid the foundation for modern cosmology. In 1915, Einstein presented his general theory of relativity, which extended his earlier work to include the force of gravity. This theory revolutionized our understanding of gravity as a curvature of space-time caused by massive objects. It provided a new perspective on the nature of the universe, predicting phenomena such as the bending of light around massive objects and the existence of black holes. The general theory of relativity remains one of the pillars of modern physics and has been validated by numerous experimental observations. Einstein's contributions were not limited to relativity. He made significant advancements in the field of quantum mechanics, particularly through his work on the photoelectric effect, which earned him the Nobel Prize in Physics in 1921. His research on the behavior of light and the quantization of energy laid the groundwork for the development of quantum theory, which revolutionized our understanding of the microscopic world. Beyond his scientific achievements, Einstein was known for his profound philosophical and humanitarian views. He was a staunch advocate for peace, social justice, and human rights. Einstein's famous equation, E=mc², which demonstrates the equivalence of energy and mass, brought forth the realization of the immense energy locked within the atom, leading to his concerns about the potential destructive power of nuclear weapons. He tirelessly advocated for the responsible use of scientific knowledge and the pursuit of peaceful resolutions to global conflicts. The study of genetics is at the cutting edge of modern science because it is revealing previously unknown information about our DNA and the workings of the living world. In an effort to answer fundamental questions about our origins, hereditary traits, and disease susceptibility, scientists have embarked on a quest to decipher the genetic code. The process began with the groundbreaking work of Gregor Mendel, the father of modern genetics, and continuing with the groundbreaking discovery of the double helix structure of DNA by James Watson and Francis Crick. DNA sequencing technology has allowed us to learn more than ever before about our complex genetic makeup. Personalized medicine, genetic engineering, and a more nuanced understanding of life were all made possible by the work of scientists like Craig Venter, who played a critical role in the Human Genome Project, and Jennifer Doudna and Emmanuelle Charpentier, who created the revolutionary CRISPR-Cas9 gene editing tool. The enormous scientific feat of sequencing the human genome has given us a wealth of knowledge about our genetic background. Through its use, scientists have been able to pinpoint disease-causing genetic variants, paving the way for more specific medications and treatments. There has been a rise in the availability of genetic testing, empowering people to better understand their own histories, health concerns, and reproductive options. Furthermore, our knowledge of genetics now extends well beyond us. Barbara McClintock's seminal research on transposable elements, as well as the discoveries of split genes by Richard J. Roberts and Philip A. Sharp, have illuminated the genetic principles that underpin all forms of life. Learning about the genetic makeup of various species helps us grasp the complex network of life's evolutionary history on Earth. We're on the edge of a genetic revolution, but there are serious ethical considerations and dangers to avoid before we can fully embrace the possibilities. The potential to deliberately shape future generations by selecting for desired characteristics, or designer babies, poses serious ethical and societal concerns. In order to ensure that the advantages of genetic breakthroughs are used responsibly and fairly, it is crucial that we approach these talks with due diligence. By studying genetics, not only are we able to better understand our history and present, but we are also helping to shape the future of medicine, agriculture, and environmental protection. We have the ability to increase agriculture production, protect endangered animals, and eliminate hereditary illnesses. But we can guide the direction of genetic research and its uses together if we continue to collaborate, establish ethical frameworks, and include the public. Additionally, researchers have set out to understand quantum mechanics, a subfield of physics that explores the strange and paradoxical properties of the quantum world. Numerous scientific giants have paved the way for our exploration of this puzzling domain, from Max Planck's groundbreaking work in introducing the concept of quantization to Albert Einstein, Boris Podolsky, and Nathan Rosen's famous EPR paradox, which challenged the completeness of quantum mechanics. Erwin Schrödinger, who developed the renowned wave equation that characterizes the behavior of quantum particles, was a pivotal role in the evolution of quantum mechanics. His seminal research paved the way for our current understanding of quantum phenomena like superposition, in which a particle can exist in multiple states at once, and entanglement, in which the state of one particle instantly affects the state of another particle regardless of their physical separation. Quantum field theory, which defines the behavior of particles and forces within the framework of quantum mechanics, was created by scientists like Richard Feynman, Murray Gell-Mann, and Steven Weinberg by building on these foundations. The strong and weak nuclear forces are better understood, and a quantum description of electromagnetism is now at our disposal thanks to their contributions to our knowledge. Quantum physics has far-reaching ramifications beyond the realm of simple curiosity. They've spawned cutting-edge innovations that are revolutionizing several sectors. By using quantum physics, quantum computing has the potential to exponentially enhance processing power, which might have far-reaching implications for areas like encryption, optimization, and drug discovery. Peter Shor and Lov Grover are only two of the scientists that have made important contributions to this field, ushering in a new age of computing. Quantum physics, however, tests not just our technical prowess but also our philosophical and metaphysical assumptions. Quantum entanglement, which Einstein memorably referred to as spooky activity at a distance, begs fundamental concerns about causation and the basis of the universe's interdependence. Philosophers and scientists like John Bell and David Bohm have explored the philosophical implications of quantum physics, igniting discussions about the nature of reality and the limits of human comprehension. The area of artificial intelligence, which has been the source of both hope and dread, has made significant progress in recent years. Many notable scientists and researchers have contributed significantly to the quest for artificial intelligence. With his revolutionary work on computability and the notion of a universal computing machine, Alan Turing, widely regarded as the founder of modern computer science, laid the framework for artificial intelligence. His groundbreaking work paved the way for future research into artificial intelligence. The phrase artificial intelligence was first used by John McCarthy, who also initiated the Dartmouth Conference in the late 1950s. McCarthy's conception of AI as a subfield of computer science devoted to the development of self-aware robots ignited a surge of excitement and laid the groundwork for decades of study and development in the field. Neural networks, which attempt to model the human brain, are one of the most significant breakthroughs in AI. Researchers such as Geoffrey Hinton, Yann LeCun, and Yoshua Bengio have made substantial strides in deep learning, a branch of artificial intelligence that emphasizes the training of multi-layered neural networks. The innovations in autonomous cars, face recognition, and translation technologies can all be traced back to their groundbreaking work in computer vision, natural language processing, and voice recognition. The proliferation of AI has infiltrated many spheres of society. Artificial intelligence algorithms are used in a wide variety of modern digital services, from virtual assistants like Siri and Alexa to recommendation systems that personalize our online experiences. AI has also made great achievements in the medical field, contributing to areas like as medical diagnosis, medication development, and individualized treatment programs. AI has the potential to change patient care and improve health outcomes, and scientists like Fei-Fei Li, Andrew Ng, and Demi Hassabis have been at the vanguard of this effort. However, with such fast AI development comes new ethical questions. Concerns about data security, job losses, and the responsibility of AI systems are rising in tandem with robots' growing capacity to make decisions on their own. Nick Bostrom, Stuart Russell, and Kate Crawford are just a few of the scientists and ethicists who have participated in these debates. They all stress the importance of exercising caution in the creation and implementation of artificial intelligence, AI, technologies to guarantee that they uphold universal values and serve the greater good. As we go farther into the world of modern science, our eyes are pulled to the heavens above, where an endless curiosity compels us to probe the depths of space in search of answers to age-old questions. Exploration of space, a manifestation of human ambition and creativity, has and will continue to hold our fascination and push the boundaries of scientific knowledge. Scientists have begun on a remarkable journey with the help of advanced space observatories like the Hubble and James Webb Space Telescopes. They have probed the depths of space and brought to light its hidden mysteries, revealing the interconnected web of cosmic marvels. Neil deGrasse Tyson is one of the visionaries who has helped us along the way of our cosmic journey. Tyson has inspired numerous people with his boundless enthusiasm for the universe and his exceptional ability to explain intricate scientific topics in a way that everybody can understand. He has been instrumental in bringing astronomy to the masses and motivating the next generation of explorers and researchers. We have found exoplanets in other star systems, and each one of them might be a home for humanity. Scientists like William Barucki spearheaded the charge on the Kepler project, which dramatically improved our knowledge of exoplanets and revealed the galaxy's rich variety of planetary systems. Discovering a new planet always makes us reevaluate our position in the universe and makes us curious about the prospects for life beyond Earth. Exploration of space has also given us a window into the past, allowing us to see how the cosmos began. Scientists like George Smoot and Charles L. Bennett used probes like the Cosmic Microwave Background Explorer, COBE, and the Wilkinson Microwave Anisotropy Probe, WMAP, to study the cosmic microwave background radiation left over from the Big Bang. These groundbreaking findings have helped us better grasp the earliest stages of cosmic history and the subsequent development of the cosmos over billions of years. In addition to important scientific discoveries, space travel has provided us with magnificent photographs of far-off galaxies, dazzling nebulae, and other wonders of the cosmos. Images from space observatories like the Hubble and the James Webb invoke feelings of awe and astonishment because they attest to the universe, beauty and majesty. Scientists and explorers have stoked our curiosity in the universe by encouraging us to test the limits of our understanding and go to other worlds. They serve as a constant reminder that the universe is ours to play in, full of secrets and mysteries waiting to be discovered and questions to be answered. In the modern period of scientific inquiry, we can't ignore the pioneers who laid the groundwork for what we know today. Brilliant minds like Stephen Hawking have shone a light on the frontiers of theoretical physics and forced us to rethink our assumptions about the cosmos. Reminding us of the value of biodiversity and our role as stewards of the natural world, Jane Goodall, the famous primatologist, has spent her life to researching and fighting for the protection of our closest relatives, the chimpanzees. It is essential to have open and well-informed conversations as we consider the successes and debates of modern science. Let us celebrate the ambiguity, controversy, and variety of viewpoints that characterize the scientific world. Join our thriving group of inquisitive minds by commenting, and subscribing to our channel. As a group, we may indulge our natural curiosity and aid in the never-ending pursuit of scientific truth by setting out on an exciting journey to explore the marvels of modern science.